In GCSE physics, required practical 8 requires measurements taken from a ripple tank like this one. One of the problems that we anticipated is that a lot of schools may not have a ripple tank. They cost somewhere between £70 and £600, and quite often with schools they might only have one, whereas with required practicals the requirement is that all pupils should have a go at taking the data. So we thought about this at Uppingham School, and our senior technician Dave Ferguson had a go at seeing if there was a way that we could create something like this, but for a fraction of the price and with equipment that can be found in any prep room. And so this is what we've come up with, and we call it the Ferguson Ripple Tank. The first thing you'll notice about this setup is that it doesn't rely on the transmission of the light through the water. What it does instead is it uses that phenomenon that you might have seen in a swimming pool, where if bright sunlight comes in and strikes the water, the waves can be seen on the reflection of the roof of the swimming pool above your head. Here, an LED lamp is shining on the water's surface. And for maximum reflectivity, we've put a mirror on the bottom, which is reflecting the wave pattern up onto this screen. Now, the entire ripple tank is just a grapnel tray, and so is very easily transportable, and of course most science departments have hundreds of these.
I've got the signal generator here, and I've taken the low output from here, so it's 6 volt RMS 1 amp max on here. That is going through to a solenoid which has got a nail and a rule stuck to the nail just to act as a beater. There are 2 masses in here which are there to stop the bar rotating, and in the circuit between the solenoid and the signal generator there is one diode put in series, and that is just here, but you could easily do that outside with a component holder. I've got a low frequency, in this case about 1 Hertz signal going through, and what happens is the solenoid is energized and pulls up the nail, then releases it and waits for the next pulse to come along.
From this point, all of the rest of the apparatus costs about £17, which, if you consider that a ripple tank costs anywhere between £70 and £600, there is a huge cost saving. But you may have noticed that we're driving this from a signal generator, and these aren't cheap. Here we've got a setup where it's a single signal generator driving the one piece of apparatus, and unless you've got multiples of these, you might find that this experiment is limited not now by the ripple tank but by the number of signal generators that you have. If you only have one signal generator, you can place it in the middle of a table and set up 3 or 4 circuits all feeding off the same signal generator. You see, what we have here is we have 2 of these solenoids working in parallel. Now, to make it work, you have to have a diode in each branch of the parallel circuit, both facing the same way, and this can be repeated up to 4 or maybe 5 times in the centre of a table.
So if you're wanting to use a replacement for the signal generator, you can build a circuit similar to this or possibly others. Basically, I have a 555 timer here which is acting as a pulse generator. There may be other options that you can use, and from that we're going through a power amplifier, and that is driving the solenoid. So the circuit here is based on a 555 timer, which are fairly cheap and easily obtainable. We have this part of the circuit here with the two resistors and the capacitor, the electrolytic capacitor, dictate the frequency of the pulses. On this side we have a PNP transistor which is in a power transistor, which is in the circuit to condition the pulse to the solenoid. And there's just a little protection that's given by this diode, which reduces any back EMF and stops the transistor being damaged.
So Dave, this will work as is, but I understand that you want to develop this further.
Yeah, I was thinking most schools have access to a BBC microbit, or Arduino, or even a Raspberry Pi, and taking an output from a flashing lamp from that, we could use this transistor circuit and a 6-volt power supply, providing they were common, to generate enough energy to to make the solenoid work, and it would be an awful lot cheaper than a signal generator.
So here you can see the replacement of the signal generator actually driving the oscillator and creating the waves. How we could develop this is we could replace the breadboard with a printed circuit. We could stow it away for its own safety in some kind of waterproof container, and we could actually make it so small that we could mount it onto the top of the solenoid. Dave, how much would all of this cost?
I think, if you've got your dishes, your trays, your battery supplies in school, no more than £20.
So for £20, you could have multiple sets of this apparatus, 5 sets for £100, and then you would actually be able to have your pupils conduct required practical number 8 in a way that I think is more authentic. It's how I think it was intended for the required practicals, that the children must use the apparatus and take data from it. And I think this is a very cost-efficient way of doing that.